Today I'll talk about measures of central tendency. Any data can be described in terms of the central tendency and dispersion of data. The measures of central tendency include mean, median, and mode. Uh, there are at least three types of means: arithmetic mean, geometric mean, and harmonic mean. In biomedical statistics, we mostly use arithmetic mean. So the formula which are used to calculate the measure of central tendency depend on the data situation. So data situation, by data situation I mean data can be in a form of a raw data or a classified data as described for discrete data and classified data with class intervals. There are these three uh, uh, situations in which data is present and we need to calculate the measures of central tendency. So first I'll talk about arithmetic mean. The formula for arithmetic mean for raw data, it is the summation of all the values of a variable divided by the number of the observations or the number of values. For classified data, it is summation of the values multiplied by their frequencies divided by summation of frequencies. So there are these two formula which are there to calculate the arithmetic mean. So if the data is present in the form of a raw data, we just need to sum up these values divided by the number of observations. And in this example, the number of observations are 8. So we sum up all the values and divide by 8, we get the arithmetic mean. For classified data, as I told you about discrete data, when there are no class interval but data is classified, we just use the formula as summation of the first we multiply the values by their respective frequencies and then we sum up all the multiplications and divide by summation of frequencies, because summation of frequencies is the total number of observations which are present in data. And the next scenario is classified data when class intervals are present. The formula is similar as I told you in my previous slide. The difference is that the xi which is used here is the midpoint of class interval. So for this in this example, the first class interval is 100 to 110. So the first xi or x1 will be 105. Then the next xi will be 115 and so on. So we multiply 105 by 11, 115 by 19. We write all those multiplications in a separate column. We summate all those multiplications and divide it by summation of frequencies. So these were the formula for arithmetic mean. Now what are the features of arithmetic mean? Since arithmetic mean is mathematically calculated, the mean can be incorporated in further complex mathematical and statistical formulae and calculations. So the mean can be used in more complex formulae later on after calculation. Uh, uh, the other feature is that it include each and every observation of the data, because you summate all the observations. So it include each and every observation. So what is the disadvantage of this feature is that since mean include each observation, it is affected by extreme values. So if there are extreme values, the mean is tilted toward those extreme values. If there is extreme value on higher side, the mean will shift to higher side. If there is extreme value on lower side, mean will shift to lower side. Hence, it is not recommended for description of data which is not normally distributed. I have given you hint before that a normally distributed data have a bell-shaped distribution curve. I'll talk about statistical distributions in my other lecture. So these were features of the arithmetic mean. Then I'll talk about median. Median is actually the middle value after arranging the data in either descending or ascending order. So for raw data, it is very simple. You arrange the data in either ascending or descending order, and you just identify the middle value, that will be the median. For classified data, formula is little complex, but this is a very important formula. It is like uh, lower limit of median class, LLM, plus this term. And this term is multiplication of these two terms, and this summation fi by 2 is step 1. I'll describe you a little bit detail in my next slide. And the CFM minus 1 stands for cumulative frequency of previous class. The CI stands for class interval of median class, and FM stands for frequency of median class. So for raw data, calculation of median or identification of median value is very simple. This is our raw data. We arrange it in particular order. In this situation, I have arranged the data in ascending order. On inspection, I found that there are middle two values. There is no single value in the middle. There are two values. So simply, I will add up these two and divide it by 2. I'll basically take average of these two values as a median. So this situation is there if there are even number of values, and here total values were 8. So it was even number. So in case of even number, we will get two middle values, and we just take average of those two values to get the median. If the total number of observations are in odd number, let us say if the total number of observations were 9, then we can just leave 4 here, and the middle value will be single, and that will be the median. So this is how you identify median for a raw data. Then for classified data, the formula is this. So step 1 is sigma fi by 2, and the sigma fi, that is the total number of observations, were 100. 100 divided by 2 is 50. So we see that 50th observation lie where? So 50th observation lies in the class uh, uh, with xi 125. So 125 is median here. This will be clear in when you will be given numericals, then it will become more clear. For classified data with class intervals, the entire formula will be used, and in this scenario, the uh, the median class was 121 to 130, and we can use this formula to calculate the median. So, what are the salient features of median? Uh, the first is that since it is not derived mathematically, it cannot be used in further mathematical calculations. So usually it is not used for further statistical or mathematical formulae. Then the advantage of median is that it is very easy and satisfactory measure of central tendency. The other advantage is that the median, since it is a middle value after arranging the data, it is not affected by extreme values. So if there is extreme value on either higher side or extreme value on lower side, the median will not be affected. And it is the recommended measure of central tendency for description of data which is not normally distributed. Then let us see what is mode. Mode is the most frequent value, most frequently occurring value of a data. So for raw data, you just see which value is occurring most frequently. So a value with maximum frequency, max fi, maximum frequency, is the mode. But for classified data, formula is little complex. So first we identify the modal class. Modal class will be that class which has a maximum frequency. Then we calculate P and Q. P is the difference between the maximum frequency and the frequency of previous class. Q is the difference of maximum frequency and the frequency of successive class. Then we apply this formula to identify the mode value. So for this raw data, uh, there are these values, and if you, by a simple observation, or you can just write the frequencies here. Frequency of 10 is 1 because it occur one time only. Frequency of 58 is 1, frequency of 48 is 1, frequency of 45 is 3. So frequency of 45 is maximum here. So 45 is the value where the frequency is maximum. So 45 is the uh, mode in this data. Then for classified data, the formula I told you before, which is used. So this is the classified data, and from this column of frequencies, it is easy to understand that the maximum frequency is 31. So 125 is the mode here, because 135 occur 31 times, and this is the maximum number of occurrence. Then the other classified data, there are these class intervals. So we use the formula for uh, mode for class interval. This formula we use. Then what are the features of mode? Since it is not derived mathematically, it cannot be used in further mathematical calculations. This is very similar to median. And the second is that it is an easy and satisfactory measure of central tendency. It is easy to identify, and it is a satisfactory measure of central tendency. So these two features are very similar to those of median. So this was end of my lecture.